Hello everybody. So here's lesson 3.1, solving quadratics by graphing and by factoring. To solve a quadratic by graphing, you've got to see where the parabola crosses the x-axis. They sometimes get called roots, solutions, x-intercepts, or zeros, and we'll interchange those at all the time. So on this one they say find the roots. They're wanting to know where does it cross the x-axis. So on this problem it crosses the x-axis when x is at -1 and when x is at +3. Example 2, find the solutions as an ordered pair. So I'm looking for x comma y. So on this one I'm going to find where it crosses the x-axis, but this time write it as an ordered pair. So this one here is at -3, 0, and this one over here is at 4, 0. So just pay attention to the directions if they ask to solve for x or if they want it as an ordered pair. Next up is solving the system of a quadratic and a linear by graphing. I must say that this is the easier version. To solve a system of a linear and a quadratic by graphing, we look to see where they intersect. Write your solution as an ordered pair. Solutions can be checked by substituting back into both equations. Left side should equal right side. So on this problem, it's hard to tell, but it looks like it's somewhere right in here. So it looks like it is at 0, -2. And if I wanted to check, I would plug this in. And I look to see, and I could use my calculator, 0 squared. I'm going to plug everything in on this right side. Plus 2 times 0 minus 2. When I plug this in, I should get -2 as my answer, and I do, so it checks here. Now I'm going to check it here. 2 times 0, take away 2, and I get -2. So it checked in both equations. Find the solution of the quadratic and the linear. Up here I have 1, 3, and down here I have -2, -6. And again, I could check my solutions by plugging them back into both equations, one at a time. So 1, 3 would check, and then -2, -6 would get checked. On the back of the notes, we have solving algebraically. To solve algebraically, we're going to use factor and solve. So this again is going to practice what we learned in previous units. Move everything to one side and make sure it's in standard form. You always want your squared term to be positive, and make sure the whole thing is set equal to the number 0. Factor, so it might be factor trinomial, factor GCF, difference of two squares. It could be anything. Set each factor equal to 0 and then solve for x. So on this one we're not going to write as ordered pairs. Alright, this one is already set equal to 0, so I need to factor this. My eyes need to look to see if there's a GCF, and I see that there's a 6. And then I look here and I have a difference of two squares. So two sets of parentheses, one's a plus, one's a minus. Square root and square root. Now you're going to put each one of these factors equal to 0 and solve. 6 equal to 0, that doesn't make sense. There's no variable, so we throw that one out. X plus 3 equal to 0, that means x is -3. And x minus 3 equal to 0 means x is +3. Okay, so my two answers are -3 and +3. Over here I need to get it set equal to 0, so I need to subtract 12 on both sides. 2x squared plus 5x minus 12 equals 0. It has to be equal to 0. So I'm going to think factors of the first, factors of the last. I'm trying to get different signs that subtract to 5. So it looks like I'm going to need, let's see, 6 and 4, 8 and 3. Here it is. So I've got x. I need the 8 to be positive. So this is 8, take away 3, that gives me the 5. Okay, now I solve each one of these. Looks like I'm running out of room here. So this means that x is equal to -4. And on this one, I'm going to get a fraction at 3/2. So my answer is 3/2 and -4. Alright, my other example, I'm going to move these two items to the other side. So x squared, I need to put it in standard form. minus 6x plus 5. To move them over, you have to do the opposite. So what two numbers multiply to give me positive 5 but combine to negative 6? So that's going to be x minus 5 and x minus 1. I put all these factors equal to 0 and I solve them. Some of you will probably be able to do these mentally. I still highly recommend that you show me all of your work. I'll be able to see what you're thinking if you actually have an accident and make a mistake. I can see where the mistake is and help you out. All right, down in the bottom part. We have a quadratic and a linear, but now they want us to use solving it algebraically. So what we're going to do is set the two equations equal to each other. We're going to move everything over to one side so that the squared term is positive and in standard form. We're going to get to factor these, and then we're going to plug in the x value to find out what the y value is so that we can write our solution as an ordered pair. All right, hang on. Sometimes this is a little painful because it's lots of math. So here we go. Here's the quadratic and here's the linear. I'm going to zoom in so we can just see this one problem. All right, so we're going to put them both equal to each other because they both say y equals. So the quadratic is equal to the linear. Now we need to move everything to one side. So how do I move this negative 3x? I'm going to need to add 3x to both sides. And how do I move a positive 12? I'm going to subtract 12. Okay, so now I have x squared minus 8x plus 16 is equal to 0. And this is exactly what I needed. Now I need to factor this. So I'm going to have both signs the same as my middle. What multiplies to give me positive 16 but combines to give me a negative 8? That's x minus 4 and x minus 4. I'm going to solve both of these factors. And this is called a double root because they're the same thing. Same thing means really just solve it once. Okay, so x is 4. I don't really need both of them, but I do need to find my y value. So I have to plug it back in. And you're going to plug it back in, substitute it back in, to the linear. Okay, so instead of, we're going to have y equals, negative 3 times, what did we find for our x? And then it's plus 12. So my y value is 0. And now I've got myself an ordered pair. So my answer is 4, 0. I could check this solution to see if it's right by plugging it back into both of my equations, the quadratic and the linear, and it will check in both of them. Let's look at example 9. So we put them equal to each other. The quadratic equals the linear. We're going to move everything to one side. Subtract the x, and then add the 1. So I have 2x squared plus 12x plus 16 equals 0. It's time to factor it. As I scan all my numbers, I see that I have a GCF of 2. So I'm going to bring out the 2 by dividing. And now I'm going to see if I can factor this again. What numbers multiply to give me 8 and combine to give you 6? Last term is positive, middle term positive, so they're both positive. So I'm looking for a 2 and a 4. Put each term equal to 0 and solve. 2 equal to 0, what's that? That's nothing. There's no variable on that one. X plus 2 equals 0, so we get a negative 2. Put this one equal to 0 and we get x equals negative 4. This time my two x's are different. Excuse me. So what I need to do is plug in each one of them one at a time and get 2 intersections. We have a little bit of room over here to the right to do that. The first one I'm going to plug in is x equal to negative 2. So I'm plugging it into the linear. Y equals, I'm going to plug in the negative 2 minus 1. So what's my y value for this one? Negative 3. So one of my solutions is negative 2, negative 3, and I could check that. Well, now I've got to check this, plug this one in and find this one's y value. Plugging it back into the linear, here we go. We're almost done. Y is equal to negative 4 minus 1 So the y value here is -5. So I would write that one, x goes first, y goes second. There you got it. We'll practice lots in class. I'll see you then.